I think we already completed the fifth and the sixth one. We have to start with the eight. Today's lesson would be the lesson 7 and lesson 8. So if I move to the lesson 7 quickly, here we have the lesson 7. So in last lesson, also we did about data analysis part ne. Habai we talked that when it comes to data analysis, so the descriptive statistics can be divided into two parts. One is for the measure of central tendency, and the other one is for the measures of variability. So this part, the left side, we already discussed with the last lesson. Now, today's we will be discussing about the measures of variabilities. What are the measures of variabilities we have in statistics scale? So descriptive statistics means represent or describe and analyze the mass data in simple terms. So for that only we are using the measures of central tendencies as well as measures of variabilities. When it comes to measures of central tendencies, we had all the averages, mean, median, mode, those ones. And for the measures of variabilities, we have what? So dispersions and what else? Variance and the standard deviations. Those measures are coming under measures of variability. That part is done. Then measures of variability or the dispersion. This is the new topic. So measures of variability or dispersion describe the extent to which the data in the distribution are scattered around the averages of the distribution and differed from the averages. What it says, measures of variability or the measures of dispersion, these measures of variabilities and the dispersions describe the extent to which the data in the, it's anyway describe how it has been what we call the scattered around the averages. කොහොමද පැතිරිලා තියෙන්නේ, කොහොමද විසිරිලා තියෙන්නේ කියලා කියන එක තමයි there they have given. So in the distribution are scattered around the averages of the distribution and differed from the averages. ඒක කොහොමද averages වලින්, when it comes to averages, it can be either mean, median or mode. We don't know. Whatever the average we are considering, ඒකට වඩා how it differs කියලා we will be considering in these variabilities and the dispersions. So now, what do we have here? Importance of measures of variability in practical terms. How we apply these things in practically. That is, changes in the market price of Odell and Mondi shares within 10 working days. So what are those price changes? What are those price? First day we have 44.39. Second day we have 40.44. Likewise, they have already given us the daily for the first 10 days daily market prices. Let's assume like that. Then if we calculate the average or if we calculate the mean as the average, then you can see from the both data sets, so from the Odell's data set as well as the entire data set which we collected from the Mondi, both data sets we have the mean. We have the mean as the we have 43.5 of mean as the mean actually. See now, by looking at these two data set, we can't say like those ones have the same mean or the average. When we calculate it numerically, we got the same answers. Are these two data sets are equal? No, right? Because for the first data, it is 44 to 39, 44, and here it is 39, 40, 44, 46, 49. These two are not exactly same data sets. However, when it comes to mean, we got the same value for the mean. Now, can we compare these two data sets only with the use of mean or mode or median? No, we can't. That's why, that's why, that's why we have to not only the averages, we have to go with the dispersion measures as well, central tendency measures, as well as the these variation measures as well. That's why we have to go. So Odell prices are more closer to mean 43.5 and Mondi highly deviated. Therefore, Odell is suitable for the investment. See, that's what here we have. In which company are you investing it? That's what we will be going to talk. How to calculate these ones, we will be talking about these ones. So what they have measured here, by looking at this data set, you can see then 43.5 now mean negative. At least the rest of the data values should be much closer to this value. Mean negative. See 44, 43.5 now, that's also fine. 40 to 43.5 a little bit far, but that's also fine. Comparatively to the Mondi one, may Odell one data set it's much closer to this mean. That's what they have given as the final decision. Okay?
Okay.
Okay. Then measures of dispersion. We will be talking about three measures of dispersion. First one is the range, the other one is the interquartile range, and the third one is the variance and the standard deviations. So when it comes to interquartile range, we already discussed about how to calculate the Q1, that is the first quartile, and also how to calculate the second quartile, which is median, and also how to calculate the third quartile, which is the Q3 values. Here, what we call this interquartile range is, that is the difference in between Q3 and Q1. Third quartile to first quartile, third quartile minus first quartile. The difference in between the first quartile and the third quartile, we will be considering about the interquartile range. And for the range now, range means actually what? Range means what we have as range. So let's assume we have kind of an data set, kind of an row data set, and also it's not ordered. So to find out the range, first what we have to do, we have to order it either from either from least data to upper data. I mean the larger one, smallest to largest, or the largest to smallest. We have to first make it as a ordered list, ordered data set. Once we make it, then to calculate the range, what we have to do, we can get the difference in between the largest value and the smallest value. That is what we call this range. That is what we call this range. These are the values. So here we have the range and here we have the interquartile range as well. And then for the detailed ones, we have the variance and standard deviations. We will be talking about the variance and the standard deviations in future. Okay, see the first one. Show how the data set is distributed. Simplest measure of dispersion, 3, 4, 6, 7, 9, and the range. Main disadvantage is the negligence of extreme values of the distribution. We will be neglect of extreme values of the distributions. That is what we have. So that is actually the range. And for the interquartile range, what we called interquartile range, as I told you, we learned about how to calculate the Q1 and Q3 in Q1 and Q3 actually in the average part, I mean the measures of central tendency measures part, but to calculate the interquartile range, that's coming under the dispersion ones. How we gonna calculate that? That is the difference in between Q3 and Q1. Eliminating the upper and the lower 25% and taking only the middle 50%, which is moderately free from extreme values. See, the previous cases, it will be affected by the extreme values. However, for the interquartile range, which is moderately free, we can't say it's completely free. However, we can say it's kind of a moderately free from extreme values here. Then, okay, shall we do these questions first? Okay. For the question set of individual observations, here you have 6, 17, 8, 10, 9. Then to calculate the range, first you have to make it as a ordered pair, ordered data set. So then 6, 8, 9, 10, 17. Then how we gonna calculate the range? That is a subtraction of the highest value from the highest value. Subtract from the lowest minimum value from the highest value, that is 17 minus 6, that is 11. Okay. And then to calculate the Q1 and Q3, Q1 means n plus 1 over fourth item, and for the third quartile means 3 times n plus 1 over fourth item. So here for the Q1, we have 1, 2, 3, 4, 5, 5 numbers. Again, a number of elements would be 5. And 5 plus 1 over 4, that is 1.5. 1.5 now, that is what we have to do. We need to add this first one and the second one, and then should divide it by 2. Then we will have the value. So for the Q3, 3 times n is again 5, n plus 1 over fourth item, then 3 times 5 plus 1 over fourth item, that is 4.5. Fifth item, that is fourth one, and this fifth one, we need to add those two and divided by 2. That is 13.5. Q3 minus Q1 is equals to 13.5 minus 7, that is 5.5. Okay, that is it. Okay. Now, earlier case is easy because this entire data set is a raw data set. However, what will happen if we have the data in frequency distributions? Can you calculate these ones quickly?
Okay. Miss,
Yes.
Miss, how to get the third item and the ninth item from the table?
Third item. Okay, third item and the ninth item from the table. That is, you have to count the frequencies. The methane third item is 5. Ne. Ehenang,
Yeah.
see the first item is here, that is 1. And 1 plus 4 means the rest of the 4 items are, again, pahewa hatarak ne. We have 5, again, a repeat of, we have, so if I now, let me write it. So this will be like this. Okay, so this will be like this. Let's assume, so if I write this data set, first value would be 2, 2 eva frequency ka 1, because of that we have only 1, 2 there. And then we have 4 5s. 1, 2, 3, 4. That's what we have like summarized it into ungrouped frequency distribution. Here the fifth item is what? Actually the 5. Because here first value is 2, and then the rest of the values we have next. We have 4 5. So 1 2 3 4. Then the fifth value will be actually 5. On the ninth item, ninth value will be what? Ninth value will be somewhere around here. That is 9. See why? The reason is Mitana Tamai 8, ninth, 10th. All these three value is what? That is 9. 9 is repeating in those three positions. Is it clear?
Yes.
Okay.
Okay, Miss.
Okay, that is it. Then you can calculate the range as well as the interquartile as well, right?
Yeah.
Okay, good. And then okay, now the earlier case is, this is for the ungrouped frequency distributions. Now we have the frequency group, sorry, again, grouped frequency distributions. That means we have the class intervals part. Can you try this one as well?
Okay.
Group frequencies. Yes, what happened? Done or still doing?
Miss, I'll send the answer.
Still doing.
Yeah, I'll send the answer.
Okay. We received the answer. Oh, oh, okay. ඒක හයි හරි. So එතකොට මේ පාර්ට් එක හරි කිෂු එකක් නැහැ. Then the answer would be, so what they're asking to calculate the range. Range when on 39 minus 39 minus 10, no, 39 minus 10, that is 29, that is correct. And for the Q1 now, n plus 1 over 4th, Q3 3 times n plus 1 over 4th, then we have මෙතන තියෙනවා එතකොට 100 point. Okay, how many values are there? Frequencies එතකොට 101 over 4 එතකොට වෙන්නේ මෙතන තියෙන value එක. Okay, so Q1 එකයි Q2 එකයි අර මේකෙන් තමයි අපි හොයන්න ඕන, right? එතකොට LQ1, that is for the first one. Okay, 1, 2. Okay, so here then what will happen? Q1, Q2. Did you calculate the mid values and do it?
Yeah, Miss, I put it for the formula.
Okay, so when you applied these ones into the formula, එතකොට LQI means the lower
Look,
one. Yeah, lower one, right? Lower boundary of the first, يعني Q1 එක තියෙන lower boundary එක නෝ. So then it would be the method 25.25 means it would be Q1 is the 25th point means 15 to 19 එක. The other
yeah.
one is 25 to 29 එක. Okay, then 15 එක means 14.5 plus 101 into, hello? Oh. Hmm. ඔව් අර මං ඔෆිස් එකේ නම්බර් එක තියලා තියෙන නම්බර් එකට කෝල් කරන්න මිස් මම දැන් ලෙක්චර් එකක ඉන්නේ ඒ නම්බර් එකට කෝල් එකක් දෙන්න හොඳේ so then what do we have? That is n plus 1 over 25. Okay, that part is correct. එහෙනම් 100 minus. For the frequencies, we have previous class intervals frequency, that is F1, the 11 over for the F would be either a current frequency into 5 means okay, then that is the Q1 is 18. Okay. What about the Q2? That is 8.75. Yes, that part is done. Okay. Now it's clear, right? So for
Yeah.
the next one, it is now this one is done. Okay. Let's move to the next part. Next part is mean absolute deviation, right? The next topic will be mean absolute deviation. I may get that. Okay, so we did this one and also this one now. So for the mean absolute deviation means now it is mean absolute deviation. You know how we gonna calculate the mean absolute deviation? Then anyway, by looking at this equation, if it's mean deviation, that means how we deviate from the mean. If we take the raw data set as x1, x2, x3, x4. Likewise, let's assume we have kind of an raw data set. So එහෙනම් what will happen here? Mean deviation means the difference of each and every data with respect to the mean. That's the meaning of this x minus x bar. Hari, is it clear? That's the meaning of the x minus x bar. එහෙනම් what this sigma says, let's assume we have 10 elements. එහෙනම් what it says, sigma I equals what we call I equals 1 to 10. We should get the difference of each and every data with respect to difference in between each and every data with respect to the mean value, and you should not consider the sign, that means positive or the negative. Anyway, you should calculate the difference, I mean the magnitude only, the positive value only. Then what you can do, once you add all these values together, you can divide it by the number of elements which you have, that is n. Is it clear? Because this part, You will need this in future ones as well, or non-parametric Kevadati. Anyway, for the mean absolute deviation, you have to calculate. Is it clear what is this what's this equation says?
Yes.
Okay, then now they are saying find the mean absolute deviation for the following data set, that is 22, 30, 18, 36, 24. Make up, we can calculate it for the raw data set, and then we can calculate it for the ungrouped data set. Then the third option will be the mean absolute deviation for the group data set. ඔන්න ඔය වගේ තුනම තියෙනවා. Likewise, we have all these three options. Can you do this question? They have given the raw data set. Now, first thing what you have to do is you need to calculate this x bar. X bar means actually the mean value. Now, once you calculate this x bar, then we can draw a table with the given data. It's 22, 30, 18, 36, 24. And then for each data set, for the entire data set, the mean value will be 26. And here we have the x minus means the difference of the raw data and this mean value. Now 22 minus 26, 30 minus 26, 18 minus 26. Likewise, it can be either positive value or it can be either negative value as well. But anyway, you have to calculate the absolute value. Absolute value the positive value. That make a modulus mark kicking, we normally represent the absolute value. That means always it's positive. And once we have all these values, we can add those values together. Then you will receive the answer as 28. 28 over number of elements, that is 5, that is 5.6. Okay, is it clear? Hello? Okay, is it clear? Imandi?
Yes, miss.
All right. Is it clear what I explained so far?
Yeah.
About mean absolute deviation? Okay, that part is done then. I'll let you know to do the questions, but before that, I'll explain these three, the difference of these three. Now, for the mean absolute deviation, we know how to calculate it for a raw data set. Then that part is done. So then we have see, question will be the set of individual observations. This is for another one. Now, make Avilla again 6, 17, 18. Okay, so they have given another data set. So 6, 17, 8, 10, 9. For that one also, they have asked us to calculate the mean absolute deviation. Okay, can you do these two questions quickly? Then
Okay.
we'll quickly move to the frequency distribution.
Okay.
Just write down the what we call only the data set and then do.
Okay.
Okay, done. The first.
Okay, Miss.
Okay, so this one is done. And for the question set of individuals, this one also same as that. First, you have to calculate the mean values. Once you calculate the mean value, then you can get the difference in between these x values with these mean values. And then you should not connect with the, you should not conduct this, you should not consider the sign. It should be absolute values. That means always it should be positive values. ඊට පස්සේ you can do the calculation. That part is easy. So once you completed these two, now the previous one is made for the mean absolute deviations. Now, then made for ungrouped and grouped frequency distributions. What does, again, how these ones are working for the mean absolute deviations, that is sigma f x minus x bar over sigma f, that means divided by the total frequency. Total frequencies. And then here, if the data set is grouped, take the class mark. Harini, as for the previous frequency distribution tables වගේම තමයි, if we have a class interval, we need to calculate the midpoint or the class value. A class value එක අරගෙන තමයි we have to apply it for the formula. Is it clear up to this point what I'm saying?
Yes.
Okay. Then shall we calculate this one as well quickly?
Okay.
Calculated mean, okay. Here we have first one, this one also you have to do, and the second step. Construct the table. First you, okay. First, what you have to do? First, you have to calculate the, again, 2, 5, this is the given table, no, with the values, with the respective frequencies. එහෙනම් fx කියලා කියන්නේ, that is the multiplication of these values with the frequencies. Again, this is for the ungrouped one. මෙතන මුකුත් there's no any class intervals here. මෙතන directly we have that data value. එහෙම වුණාම, how we gonna calculate it? First, you have to calculate the mean value. That is the addition of the sigma fx divided by sigma f. Once you calculate these ones, then you can go with this entire. Hello? Haryana. Okay, so then what will happen here for the second step? We have to calculate the entire data table. First, the given row values are there, then the frequencies are there, then the mean value, what we already calculated is there, and then the difference, then the absolute value of the difference, and then we can calculate the final value. එතකොට final value වෙන්නේ, since this is frequency table, එහෙනම් it would be what? It would be how we calculate that one. How we calculate this one? How we calculate this one, that is with the f times frequency times x minus x bar divided by sigma f. That's the equation you have. Okay? Okay, just try the ungrouped frequency distribution part. Sampurni.
Okay, miss.
Yes, Simadi. So these ones
Wait,
are
I said,
okay. You have already sent these ones. That part is done. So that is for the ungrouped frequency distribution. Okay. Then ungrouped and the grouped frequency distribution. So again, the same thing with the frequencies. If the data set is grouped, take the class mark as X and apply the above same formula. We can apply the same formula for that as well. So this part also, it's clear. Did you do this one as well? 6, 17, 18, 6, 17. 6, 17, 8, 10, 9. So likewise, you can do the same thing for this as well. So that's also, you can manage it. So now these ones now, it's already fine. Now what will happen for the grouped frequency distribution? Okay, this part also you can do, no? What about this one? I mean,
Miss,
10 to 14th one, Tamai, you did it, right?
yeah, I did it.
Okay, you did it. That's also fine. Now, the here what we have is this is for the variance. Variance means now then earlier when it comes to what we call the measure of dispersions, you should know about the variance, interquartile range, as well as the earliest one was the range. Poetic range, interquartile range, and now we have the variance. So variance means then previously we calculate the mean absolute deviation. Now here for the variance means that is actually then attana you already saw that we calculated it as x minus x bar modulus or the absolute value. Here in variance we have removed this modulus mark. We have removed this modulus mark and then what we have done, we have squared it. Api make a completely squared kalatina. We are taking only the, we have taken only the positive values. By positive values, this is with the square terms. Now what will happen? For the variance, we can use either sigma squared or else we can use either s squared. Basically, if it's sigma squared, we normally use it for population variance. Capital S squared is for, again, S squared is for the sample variance. Now, what will happen here? So, how the equation works, the same thing, sigma x minus x bar squared over n. X minus x bar squared over n. Hari. Then this difference now we can take it. So there's nothing to consider as absolute value. We can directly get the squared values and divided by n. Hari. Then that is for the individual observations. What will happen for the grouped or the ungrouped frequencies? You have to multiply it with the frequencies, relevant frequencies. The middle part is same. Again, you have to multiply the same respective differences with the respective frequencies and then should divided by the sigma f. Sigma f is the total frequency value. Sorry, is it clear?
Yes.
So therefore, variance is a measure of how far a set of numbers is spread out. You should know then the variance is therefore it's a measure of how far a set of numbers is spread out. That's what we call it. Correct. Then, okay, can you try to find out the... okay, before that, now this one is done. You should know the variance equation. Variance, the equation which we have to calculate the variance for the individual observations, as well as the other one would be the for ungrouped and the grouped ones. So there's another alternative equation as well to calculate the variance. That is variance x how we gonna calculate it? What is the difference and the how this works? See, sigma fx squared over sigma f. This part you can directly calculate it from the table. හරිනේ මෙන්න මේ table එකෙන් you can easily calculate it. So whatever the frequency table we calculated, we can easily calculate these values. Sigma fx එක. එහෙනම් sigma fx squared. Then earlier we had only sigma fx, but now we have sigma fx squared. එහෙනම් whatever the raw data we have, we need to multiply. Multiply means we need to square. For example, if the raw data set is 1, 3, 4, likewise, then here x squared values will be 1, 9, 16, likewise. Then this should divided by sigma f. Sigma f is the total frequency value. Minus, then what you have to do? Sigma fx divided by sigma f ගේ complete squared එක. These are actually kind of an equation. Equation means actually it's a what we called equation is actually then these ones now are they give you these equations? I mean during the exam?
Yeah.
Yes, right? Okay. So
Yeah.
then if they if they are giving you, then that's fine. So is it clear what it says?
Yeah.
Okay. So then that is there. So what do we have? Okay. If we know the variance, then we can easily calculate the standard deviation. What is the connection in between the variance and the standard deviation? What is the connection in between the variance and the standard deviation? So the connection is actually square root of the variance will be, square root of the variance will be the standard deviation. Square root of the variance will be the standard deviation. That's what we call as the standard deviation. Now here, එහෙනම් this is the equation where we calculate the what we call variance. එහෙනම් once we have that value to calculate we calculate the square root of this given value, that is the standard deviation. Okay, then for the sigma will be square root of sigma f x minus x bar squared over sigma fx. The same thing. This is for the frequency group. Again, this is for the what we call this is for the raw data set, but this one is for the grouped frequency data distributions. Here we have only raw data. Again, that is for the ungrouped one. එහෙනම් we can have another data set for the what? Grouped one as well. These are the two equations. මෙතන SD means the standard deviation. Sigma means again the variance square root එක. That is what they have mentioned. Is it clear up to this point?
Yeah. Means I think they don't give the formulas.
ඒකනේ, they don't give the formulas.
So we have to study all, right?
Yes, you should know. That's easy actually. So when it comes to variance, that is x minus, sorry, x minus x minus x bar squared should divided by n. For the entire data set, you should do this. N means the number of, n කියලා කියන එක if it's raw data set නම් that means number of elements. එහෙම නැත්නම් if it's frequencies නම් this n will be converted into sigma f because the total frequencies, total addition of the frequencies. Okay?
Okay.
Then that part is done. Okay, see. Then question set of individual observations. Now, okay, this is a complete question. Shall we do this quickly? How many pages we have to come?
Okay.
Slide set 22 and 34. Okay, here we have the calculations. lecture එකක් නම් තියෙනවා 10ට නේද ළමයි ඇවිල්ලාද? So, yes, let's do this quickly for the set of individuals observations. කරොත් තමයි you can ඔයා මගෙන් ප්‍රශ්න වගේක් අහලා තිබ්බ නේද මේ whatever you did. Let me download that one as well.
Yeah, miss.
Okay, I'll download that one.
Okay, miss.
අපේ group එකේ ඉන්න ළමයිගේ list එකද ඔයාලට ඕනේ? මට තේරෙන්නේ. ගන්න කියන්නේ course fee එක. හා. එහෙනම් අපි ඒකත් ගමු. මම ඒකත් දාන්නම්. මම දැන් අනිත් messages ටික දාන්නම් එහෙනම් group එකේ. So here for this question we have, yes, that is from 20, 12, 18, 21, 23 acre, 0, minus 8 minus rho acre. Then the equation will be this, and yes, the calculators are allowed, right? For the exams?
Yeah, miss. Yeah.
Okay. Then up to this point, it's clear. Then the next one is earlier this was can raw data set ne එහෙනම් the same pattern we have the ungrouped frequency distributions. So for the ungrouped frequency distributions එහෙනම් for the ungrouped කියලා කියන්නේ there's no any class intervals thing, we have only the raw data set. එතකොට ඒක අරගෙන again x with the frequencies and the effects, then first you have to calculate the mean value. Once you calculate the mean value, then you can again build up this entire frequency distribution table with relevant to that. That also, yes, just do this one as well for the
Okay.
ungrouped frequency distributions. The other one, if I download whatever you sent me, question system, I tried this once in lesson 6. The previous ones, whatever you have already completed in lesson 6, those ones, it's fine, right? You can manage it now.
Yeah.
Okay.
Yeah.
Once we do these ones. Okay, do this table as well quickly. Okay, done.
Okay, miss.
Then that part also fine. So then value is also fine. This part is fine, right? Okay. Then now what we have is now the entire variation part is completed. ඒ කියන්නේ, so when it comes to variation, if I summarize what we did, so we should know how to calculate the range. We should know how to calculate the interquartile range. And then we should know how to calculate the variance and the standard deviation. So for the variances and the standard deviations, gattahama, we have three types of things you should know. First one is for the row data set, and second one is for the grouped data set. The last one is for the ungrouped data set. That's how it is. So likewise, you should know how to calculate this variation. Once you know how to calculate the variations, anyway, the standard deviation is the square root of the variations. එතකොට ඔය ටික තමයි the entire thing what we have so far, what we had so far. Now the next topic is the coefficient of variation. So for the coefficient of variation means that is kind of a ratio. A ratio king, what we normally called, so that is coefficient of variation. That's what we call the CV. Ehang CV is equals to how we gonna calculate it. That is the it's a kind of a ratio in between the variance and the mean. Not the variance actually, standard deviation and the mean. Sigma over mu times 100. That's what we call the coefficient of variation, COV or else CV. Now, this one is for the population. See, population because all these parameters are with the population parameters. Now, here for the COV, coefficient of variation, this is the simple x and simple s and x bar. That is actually for what? This second equation is for the sample. That is the difference in between the first equation and the second equation. When the coefficient of variation is greater, group is more variable and less stable, less uniform. And then when the coefficient of variation is less, then the group is less variable, more stable, more uniform. Coefficient of variation, if the coefficient of variation is high, then that means the group is more variable. ගොඩාක් වෙනස් වෙනවා. ඒ කියන්නේ with respect to mean value or the any other average value, the dispersion is really high. හරිද? හැබැයි when the coefficient of variation is less, මේ අපි calculate කරන whatever we are calculating it here, the coefficient of variation is less, then the group is less variable. Group will be less variable and also it will be more stable and more uniform as well. That's what we have. Okay, is it clear?
Yeah.
Okay, then question. Okay, so the question is the salary scales of two departments of a company have given below which department has a high variance in their salary scale. See the question type which they have given us. So they have given, now this is kind of a grouped data set, okay, daily wage with the number of employees. We have two set of number of employees with the category A and also the category B. So now what they are asking, the salary scales of two department. May I will department A, this one is for the department B. Of the company have given below, which department has a high variance. To calculate the high variance, what we have to do? What we have to do? What do you think? What you have to do? First, you have to calculate anyway the coefficient of variation. එහෙනම් to calculate the coefficient of variation, you should know how to calculate the mean as well as how to calculate the variance, not the variance. So variance again, we have to calculate the standard deviation. එහෙනම් from that only we can calculate the standard deviation. එහෙනම් first you should calculate the mean value and then you should calculate the sigma. That's what we call the standard deviation. Hari, shall we do it quickly?
Okay.
So out from that, once you have these values, you should be able to compare with this given statement. See the method they have given us. Making, you should be able to write the final decision or the final conclusion what we have so far. Okay. Okay. Let's do the table first. Evan. Yes. Let me check my bags. You can see. Well, hello, do it. Marks අඩුයි කියලා පේපර් එක ලියලා නැතුව ඇති හරියට. assignments වලින් ලකුණු 20යි පුතේ calculate කරන පේපර් එකෙන් මුකුත් ලියලා නැද්ද දන්නේ නැහැ කියලා.
ඒ වුණාට මම ඒකට සම්බන්ධ පාඩම් කරේ මොකද මට ඒක තමයි ඉස්සෙල්ලාම තිබ්බ සබ්ජෙක්ට් එක. ඊළඟ පටන් ගත්තේ එක්සෑම් එක තිබ්බේ ඒකට. දැන් මායි යාළුවෙකුයි පාඩම් කරේ. යාළුවා පාස්. එයාට 100ක් තියෙනවා. එයා ජෙනරල් කරන්නේ කෙනෙක්. මේ මගේ එකේ E එකක් තියෙනවා. අපිට මේ
recorrection දැම්මනේ.
ඔය
recorrection ආවම මම බලන්න. recorrection එක ආවම ගොඩක් වෙලාවට නම් changes වෙන්නේ නැහැ. සාමාන්‍යයෙන් maximum marks දීලා තමයි ඔය තියෙන්නේ. බලමු අපි.
අනේ මම දී පරිමාදේ නැත්නම්
මම අති කියලා දෙන්නේ නැහැ.
මට ආයෙත් එතකොට මට දැන් බැරි වෙලා මේ පාර කරා කියන්නේ මේ සෙම් එකේ ඒක ෆස්ට් සෙම් එකේ තියෙන කන්නේ.
ඔව්.
එතකොට මට මේ අමුතු දෙකේ ගන්න බැරි වෙලා.
ඒක පොඩ්ඩක් exam unit එකෙන් තමයි පුතේ අහන්නේ. ඒ ක්‍රයිටීරියාස් ගැන නම් මම එච්චරටම අවෑ වෙලා නැහැ. පොඩ්ඩක් අහලා බලන්න exam unit එකෙන් එහෙම කරොත් මොකද වෙන්නේ කියලා. මම බලන්නම් මගේ site එකෙන් මොකද්ද කරන්න පුළුවන් කියලා අනිවාර්යෙන් මේ මම සාමාන්‍යයෙන් නම් marks දීලා දෙන්න පුළුවන් maximum. so එහෙම තමයි තියෙන්නේ මම බලන්න. ඕකටත් ඔයා email එකක් දාලා තියන්නකො index number එකයි ඒ ටික මේ F number එකයි ටික මම ඒකෙන් බලන්න.
මම මැනේජර්ට දැම්මා.
මට email එකකුත් දාලා තියෙන්නේ. right හරි. ඔයා විස්තරේ කියලාම දාලා තියෙන්නේ. right හරි. මම මේ එකෙන් ගන්නවා.
රීකනෙක්ෂන් කවර් මේ දැන් කවර්
රීකරෙක්ෂන් ඔයගොල්ලන්ට කවුද ක්ලෝස් කරේ ඊට පස්සේ
ගොඩක්
එහෙනම් තව ටික දවසකින් ඒවි.
ඒක
අපිට
මම අරගත්ත අහන්නම් ගොඩක්.
හරි.
thank you.
okay. Grandmother. Irene? Oh, thank you. Okay.
Miss,
Yes, done?
Louis, can you explain that?
Okay. So the thing is, the question, whatever they're asking is the salary scales of two department of a company have given below. Which department has a high variance in their salary scale නේ. එහෙනම් high variance එකක් තියෙනවා නම් what should be ඒ කියන්නේ what should be there? So high
Means
variance එකක් තියෙනවා නම් the coefficient of variation should be high, right? So we learned when the coefficient of variation is greater, then they have already mentioned that the group is more. So group is more variable. That means the variation is high. So එහෙනම් what you have to do for these two separate data sets, I mean the group A and group B, you have to calculate the coefficient of variation first. හරිද? එතකොට actually here we have two data sets නේ. ඒ කියන්නේ one data set is daily wage with the group A data. The other data set is the daily wage with the what? Daily wage with the group B. Again, department B data. So one table will be this for the daily wage with the department A, and for the second set will be the daily wage with the department B. Hari. එහෙනම්, can you calculate those two? Can you calculate the difference or the coefficient of variation for those two separately? Is it clear now what I'm saying? If they ask you to comment on the comment on the variance in their salary scales, they can comment on the variance, then what you have to do? First, you have to calculate the coefficient of variation. Once you calculate the coefficient of variation, you can select in which data set. I mean, whether in department A or department B, whether in department A or department B, the variation or the variance is high kila, we should be able to calculate. Or we should be able to look on that. Coefficient of, if the coefficient of variation is high, that means what we have? Coefficient of variation එක high නම් what will happen? That is actually the මොකද වෙන්නේ? Variance of that entire data set is high. Is it clear? Then to do that, you should calculate for the department A, what would be the mean value? Department A, what would be the mean value? And also the variance. Variance means once we calculate the variance, we can have the standard deviation. ඔය විදිහට දෙකම data sets දෙකට වෙන වෙනම හොයලා, you will be able to finalize that. Okay, just do it.
Okay. Yes.
Yes. Did you send me? No, right?
I'll send this.
You were calling to me. මොන හරි issue එකක් තියෙනවද?
Miss, I'll do and send, then you can check.
Okay.
Miss, I think the answer is wrong.
Ah, okay. Send me, I'll show you how to do it. So here,
Okay, Miss.
you send to me. So let me open the question now. Okay, now the issue is so 200 to okay. Okay, that means 300, 500, 700, 900, 1,100. Frequency is 180. Okay, that is for the A. No. Okay, then the mean value is, then you have to add all these values. Again, first you have to, did you calculate, did you send me the all workings? Okay. Then 522.82. Okay, so then 522.82. Then the difference will be, yes, this is for calculate the variance, right? Sigma minus x bar squared divided by, okay, so here sigma minus x minus x bar squared means x will be 300, 300 minus 522 point, okay, this amount make a square. So this amount squared
Miss, is the main part correct?
yes, mean is first you have to multiply this mid value with the x value. Mid value with the frequencies, relevant frequencies. So the sigma fx will be 160 times 300 plus 120 times 500 plus 250 times 700. Likewise, then should divided by 1,000. The method is correct.
Hmm.
Maybe this is kind of a practice question. But for your exams now, they will give you kind of a proper one.
No, Miss, the thing is, I got like bigger values, so I thought it's wrong.
No. So anyway, the mean value is also within that period. 300 to 1,000, 522 point. By looking at these values, for the A now, making for the first category we have 100, from the second category we have 120, third category we have 250, fourth category 220. Yes, then that means anyway it would be, yes, correct, 522, 522.82. You can get it as 523 as well.
Yeah.
Once you calculate the variance, you should calculate the what? You should calculate the this one as well. I mean, you should
Okay.
calculate the, yes, standard deviation as well.
Yeah.
සර් සර් මම පසංගි සර් මේ හෙට දැන් ඩිප්ලෝමා 4 එකේ ලෙක්චර්ස් පටන් ගන්නවානේ. එතකොට හෙට හැබැයි අපේ බැච් 3